All right, hello people who are watching this video. This is section 4.3. Yeah, section 4.3. Here we go.
I see it.
Shh. All right, I'm gonna start this up here at the top. Write some of this stuff down. Before. Here's what we were doing before. Okay. Here's what we were doing before. Before, like Wednesday's lesson, what we just turned in today, they would tell us that we are trying to prove that triangle ABC is congruent, same shape, same size as triangle like DEF, let's say, okay? And in order to do that, we just got done with a proof doing that, we would have to check off 6 boxes, right? Mainly that all 3 angles are matching each other and all 3 sides are matching each other, right? Make sense?
Yep.
Yes. Now they're going to simplify it. They're going to make it a lot easier.
I can't spell. Wait, so
this is going to be easier than what we were doing before, okay? We're doing proofs, okay? But these are the easiest type of proofs ever. I love these proofs. These are my favorite type of proofs if you could ever have a favorite type, right? These are my favorite types of proofs because this simplifies things, okay? So we just did a proof where we had to check off all 6 boxes, all 3 angles, all 3 sides, have them all in my inventory. And then after finally saying that, I could say that those triangles are congruent. Now, we have these 2 things going on. We have SSS and SAS, and let me show you what this does, okay? So here's my 2 triangles, let's say, okay? All right, listen to this really carefully. Here you go. Now, we don't have to check 6 boxes. We only have to check 3 boxes, okay? Because this is how this works, okay?
Side, angle, side.
Yeah, if I have 2 triangles and this side, hold on, this side matches this one, and this side matches this one, and this side matches this one. Okay, listen. Shh. If these 3 sides matches those 3 sides, the angles have to be the same. Like there's no way they're not the same. Those 3 angles have to match, so we don't have to check off the angle boxes because there's no other option. If the sides of the 3 sides match the other 3 sides, the angles by default have to follow. So we only have to check off the sides rather than doing the angles as well. Okay, now let me show you. This does not work in reverse. So if we go to try to do AAA, which is angle, 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 right? I talked about this the other day where I said you can have an equilateral triangle where all of them are 60s, and I can have another equilateral triangle where all of them are 60s, but those triangles are not congruent, right? So if all 3 angles are matching, it doesn't necessarily mean that they're congruent. But if all 3 sides are matching, then they have to be. Does that make sense? They have to be the same, okay? So this is not true, not congruent, okay? Just because the angles match does not mean that the sides are also matching. But if the sides are all matching, then the angles have to match, okay? That's how that works, okay? Let's talk about side, side, side.
Wait. Just listen. How can you not hear it? I hear it now.
Oh, it's so fun. It's so fun. Okay? All right, side, angle, side. Ready? If this side matches this one, and this side matches this one, the angle, by the way, that we're talking about, this is side, angle, side, if you didn't figure that out already. Those 2 sides, the angle has to be the one between the 2 sides. So which angle has to match?
The left corner.
The left corner, right? This angle has to match that one, okay? They are saying that if this takes place and you have a side and an angle and a side, matching a side and an angle and a side, I don't even have to talk about this side in relationship to this one. I don't have to talk about this angle, and I don't have to talk about this angle. Those 3 other things have to also be the same. Does that make sense? There's no option. If the side and the angle and the side match, the other side and the angle and the other side, the other 3 elements, the other 3 boxes that we used to have to check, they don't have to be checked anymore. Does that make sense? Okay? By default, they have to be the same, okay? So let's do this. Let's go to, do you guys have your green sheet? Let's go to your green sheet. Let's go to your green sheet.
No.
We're going to write down postulate 4.1 and postulate 4.2. Your green sheet. Postulate 4.1, postulate 4.2. This one is side, 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 and this one's side, angle, side. Okay, there you go. Side, 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 angle, side. Got it? Great. Side, 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 angle, side.
That's great.
Keep it moving right along because we got not very long left. Okay? Side, 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 angle, side. Okay? I'm going to say if 3 sides match, I'm really paraphrasing. If 3 sides match 3 sides, if three sides of one triangle match 3 sides of another triangle, then the triangles are congruent. Okay? If 3 sides of one triangle match 3 sides of another triangle, then the triangles are congruent. Here's my 3 things going on.
4.1.
Okay? Like this one matches this one matches this one, and this one matches this one. I don't have to talk about the angles. By default, those are already congruent. Okay? Okay? Good?
No.
That is side, side, side. I have to have 3 sides matching 3 sides. Then I don't even have to talk about the angles because by default they have to be the same. Okay? All right. If 2 sides and angle between them match, then the triangles are congruent.
Wait, for the top one?
Yes.
Wouldn't it be... Oh, yeah. Just kidding.
Okay, then the triangles are congruent. If 2 sides and the angle between them match, then the triangles have to be congruent. We don't have to talk about the other side and the other 2 angles. They have to be congruent. Okay? All right, so let me put on my marking here. I'm going to quiz you. You ready?
No.
Okay, there's that. I'll zoom in a little bit.
And one angle?
And the angle between them. So it's one angle, but it has to be the angle between them. Okay, so let's talk about the angle between them. Let's say I am able to say that this side matches this one, and this side matches this one. Which angle has to be the same? The top one, right? It has to be the angle in between those 2 sides. So in order for that to be side, it has to be the angle between them. It has to be that top angle. Okay, make sense? Good? Great. Great. Okay, those are the 2 things that we're writing down on our green sheet. Now we're going to do some proofs and be done. We got 2 proofs and another example.
Not gonna lie, I kind of.
And then we will be done. Okay? All right, good? All right, let's get some stuff done here. Here we go. Okay, we got to move right along. Example 1. Write this diagram down because it got like it did not get copied. Okay? So put that diagram on example 1. It did not get copied. There's HJGLK. Add that to your thing.
Where's this at?
Okay, on example 1, we don't have a diagram. You need a diagram on example 1. Okay, that's what the diagram looks like. Okay? And then over here, when we go to do our proof, I'm going to put inventory, right? We always take inventory off to the side, okay? In my inventory, I need 3 things now, not 6. Just 3 things, okay? So as we go through this, we're going to list out. We need either SSA or we need 3 sides, right? Okay? So the first thing they give to me is this piece of information. GH and KJ are the same as each other, okay? So I'm going to mark that on here. GH is this side, KJ is this side. So I have those 2 being the same. The 2 outside segments are the same measure. Got it? That gives me what in my inventory?
Side.
That gives me a side, right? Got that? Okay. The next piece of given information. Do you see where I'm pulling this from? HL is congruent to JL. Okay. HL is the inside ones and JL is the inside ones. So those guys are the same. That gives me another side. Okay. And then there's one more piece of given information. It says L is the midpoint of GK. L is the midpoint of GK. So that's all my given. Okay, so this guy is the midpoint. That doesn't necessarily give me a side yet, right? I need my 3rd side probably to be matching, otherwise an angle, right? I need my 3rd side to be matching. If L is the midpoint, you guys have all that down? Can I zoom in a little bit?
Yep.
Yep. Okay, so if L is the midpoint, what can I say from that? If this guy is exactly in the middle.
The GL is the same as OK.
Okay, GL, which is this guy,
Or
and I'm going to call it
KL.
I'm going to call it KL. So GL and KL are the same, right? Okay? So I'm going to say segment GL is going to be the same as segment KL. How do I know that that's true?
Midpoint.
Yeah, that's the midpoint theorem. They tell me it's the midpoint, so by default, by the midpoint theorem, I know that those 2 sides are the same, and now I have a third side in my inventory. Okay? I have checked all 3 of my boxes. Check, 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 right? That's all the only 3 that I have to do. So what do I write next? I write this prove statement. Okay, this is always my last step, is what we're trying to prove. So triangle GHL is congruent to triangle KJL. Got it?
What is that?
Okay, and how do we know that?
Definition of
No. Postulate 4.1, I'm going to say SSS. Side, 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 right? By all 3 sides matching, we know that those 2 triangles are congruent, and we're done, right? Okay? All right, while we're on the thought process of doing proofs, okay, let's skip example 2. We're going to come back to it, and let's go on to example 3. Okay, can we?
No.
So we get both proofs, both proofs figured out, okay? There is a typo on this proof. Fix this. It should say WZ and XY are parallel to each other. So find that in your notes and fix that. It should be WZ and XY, okay? WZ and XY. I'm going to do this. I'm going to draw this diagram a little bit better. Like a little bit bigger. You don't have to redraw it. I'm just redrawing it, okay? And I'm zooming in on the part that they're looking at. So like this chunk right here. Okay, that's the part of it that we're looking at. And we're looking at those 2 triangles, okay? All right, but it does have a typo, so fix that typo in the paragraph, okay? What?
W, that top one?
W is this top one right here, this corner.
Oh, I see. You drew it in.
Yeah, I drew, yep. I just took that chunk and I redrew it over so that I can mark it better and it's bigger. Okay, all right, don't forget your inventory off to the side over here. I'm just going to say INV. Okay, taking inventory super, super, super helps you because then you can see what you have and what you're missing, right? Okay. All right, so we are trying to prove that 2 triangles are congruent. The triangles are WXZ. Which one is that? WXZ triangle.
The top.
This is like the top left one, right? That triangle is congruent to YZX. So we're trying to say that those 2 are the same shape and same size, right? Like they look like they've been rotated, right? Rotated around, okay? So we're trying to prove that those 2 triangles are congruent. They tell me this information. You see where I've circled? That's my first piece. WZ is congruent to YX. WZ is congruent to YX. Okay? WZ. WZ is this left side and YX is this left side, or the right side. Got it? WZ and YX. That gives me a side that matches. Got it? Okay, then the next thing that it tells me is that WZ, which is this guy right here, is parallel to XY. So those 2 lines are parallel to each other. All right, that doesn't really tell me a side though. It tells not congruent. Yeah, that might help me figure out some angle stuff. Okay. So I'm going to write that down, and I'm going to say that's all my given information. But that doesn't give me any more information. It just tells me that those 2 lines are parallel. So I'll use that here in a minute, okay? I know that I need 2 more boxes to check off. I need 2 more things, right? 2 more things. All right, what else can I say from this diagram that it has to be the same?
If those are parallel, wouldn't they have to be parallel on the top and bottom too, though?
Maybe. That's what we're trying to prove. Because one of them could be like this and the other one could be like this. You see? So they wouldn't necessarily have to be parallel, the top and bottom. They're gonna be, but we don't necessarily know that. What else do we know?
We know.
Oh, look at this. Look at this. Mackenzie just said this. ZX is the side that they share, right? So she says ZX for the top triangle is congruent to ZX for the bottom triangle, right? Like they're the same side that they share. What's that called? That's the reflexive property. Reflexive property. Okay. All right. That gives me another side. So I have 2 sides. Perfect. Okay. This one, by the way, if you didn't already know, we're using side angle side. So we need the angle, right? So I've got this side is matching. Okay. So if I look at this triangle, this top one here, which angle do I need to pick on?
Oh, the Z one.
The Z one, this guy right here, okay? If I'm looking at this triangle, it has to be this X one right here. Are those 2 things the same?
Yeah.
Why?
Because they're parallel.
Not consecutive interior. Here's my two parallel lines, and this is my transversal.
Yeah.
You see them? Are they alternate interior angles?
Uh-huh.
Sure they are, right? So alternate interior angles, okay? And now I can't just call it angle Z and angle X. I've got to call them something different. Okay, so if I'm talking about this angle right here, this is WZX. WZX is how we name it, okay? Then the other one has to be YZX, or excuse me, YXZ. WZX and YXZ, okay? And so then that gives me an angle. All right. Now, according to my inventory, it looks like I have SSA or ASS, which is a naughty word. Right, we're going to talk about ASS later on, okay? But SSA, we're going to talk about SSA, okay? According to my inventory, the way that I have them listed here, it looks like SSA. But in the diagram, it's actually side angle side, right? The angle is between the two sides. So just so you know, your inventory, the way that you found them may not necessarily be in order, just as long as you have them in order on the diagram, right? So we do have a side and then an angle and then another side going on. And my prove statement is going to be this one right here. We are trying to prove that triangle WXZ is congruent to triangle YZX. Done. Okay? Good?
Triangle what?
WXZ and YZX. Okay? We're skipping example 4, but we got to go back to example 2 really fast. Really fast. Okay? We're going to run out of time. We got to go really fast. Ready? Here you go. Okay. This one is not a proof, but we are trying to show that these two triangles are congruent or not congruent. We have to graph both triangles. We've got triangle ABC and we've got triangle EFG. So graph those both really quick, and we will see if they look the same.
1, 1.
Okay, graph them fast if you can. Okay, that's what part A is. Part A, graph the triangles on the coordinate plane. Perfect.
1, -1.
Got it. B.
2, -1.
I'm trying to go as fast as I can because we're going to run out of time.
Okay.
B, if you look at those two triangles, do they look congruent or not congruent? Do they look like the same shape and same size? I don't think so. I'm going to say no question mark because I think that maybe they look quite a little different. Okay? So we're gonna try this, and we're going to talk about triangle ABC, which is the top one, and we're going to talk about triangle EFG, which is the bottom one. EFG. Okay? All right. So triangle ABC and triangle EFG, okay? All right. If we're trying to look at the sides of the triangle matching the sides of the triangle, okay? One side of the top triangle is side AB, right? And if we're trying to look at the length of that, we have to do the distance formula. No, it's actually not terribly, it's pretty fast, okay? So we're comparing A and B, and the distance formula looks like that, okay? If we compare A and B, I'm looking at 1 and 0. How far apart are 1 and 0? 1 unit. How far apart are 1 and 3? 2 units, right? Okay. 1 squared is 1, 2 squared is 4, so that is the square root of 5, okay? Then I have B, C is another side. So I'm comparing B and C, and I do the distance formula again, okay? From B to C, if I look at those, B is 0, C is 2, that is 2 units apart. And then we have 3 and 5, which are another 2 units apart, okay? 2 squared is 4, 2 squared is 4, that is the square root of 8. That side is the square root of 8, okay? What's my third side called? CA or AC, doesn't matter what you call it, okay? All right, we're going to figure out how far apart those guys are. All right, A and C. A is at 1, C is at 2, so that is 1 unit. A is at 1, C is at 5, that is 4 units, okay? What's 1 squared plus 4 squared?
17.
The square root of 17, perfect. Okay, there he is. All right, EFG, because we're going to run out of time. EF is the square root of 8, I believe. No. EF is the square root of 17. Okay, FG. We just did the distance formula between them. Okay, I'm just giving you these. FG is the square root of 5. And EG is the square root of 18. Are those two triangles congruent?
No.
No, because
18 and
These
5
two
don't
sides.
match.
Oh, no. Not those two sides. 18 and 8. So that is proving not congruent. Okay. All right. Hold on just a second. Hold on just a second. I'm not talking about Claire. Claire can go. Okay. On your homework assignment. On practice side, do all of them, but skip number 2. I'll let you skip number 2 because that's another long one. So, on practice, do all but skip number 2. All but skip number 2. Okay? On the other side, just do number 1 and number 4. Okay? All but skip number 2 on practice. Skills practice, do 1 and 4. Okay? Have a happy weekend. Goodbye.
Goodbye.